So the first mistake that I see students make, kind of all the time, and it's a fairly basic one, and it's just going to go into our rules of logarithms. Okay. So if I have like a logarithm equal to a logarithm, it's really, really easy for students to remember this rule, right? So this is going to be what I call the dividing out mistake. So if you remember the rules of logarithms, and when we first are learning to solve logarithms, we say if you have a logarithm with the same base equal to another logarithm with the same base, we can apply this one-to-one property of logarithms, and basically those logarithms are going to cancel out, and we can set the argument of one logarithm equal to the argument of the other logarithm. This makes our life all very, very easy, right? So all I simply need to do is when I see a logarithm equal to a logarithm, I can basically just take those arguments equal to each other and then go ahead and solve. In this case, it's a linear equation. So solving this is going to be very, very easy. But here's the problem, because obviously, when we're working through problems with logarithms, like, yeah, there's some easy examples, right? And that one's following um, like a fairly basic, rule with logarithms. But then again, we start getting some more difficult types of problems that we have to deal with. However, students want to make things easy, right? We all want to make things easy. So what do they see when they see an equation with all logarithms? They say, hey, why don't I just cancel all these out and set the arguments equal to each other? Unfortunately, ladies and gentlemen, that is not the one-to-one rule for logarithms. The one-to-one rule for logarithms only can be applied when you have a logarithm equal to another logarithm with the same base. Now, these all have the same bases, but we do not have a logarithm equal to another logarithm. So you might then say, well, Mr. McLogan, what do I need to do? Well, what we need to do is apply our rules of logarithms to go ahead and simplify this. First of all, I'm going to say, no, can't do that, okay? But what you can do is you can use your rules of logarithms to combine here. I can rewrite this as a log of 5 times a x minus 2 equal to a log, that's supposed to be 100. I just wrote it really bad. So a log of 100. Now I can apply this one-to-one rule, and I can say a 5x minus 10 is equal to 100. And there, ladies and gentlemen, now you can go ahead and solve.